Hey, this is Mr. Neff here. Today we are taking a look at lesson 5.1 where we are dividing numbers by powers of 10. Our lesson essential question can be found right here. It is, how is the solution affected when dividing powers of 10? I would like you, if you haven't already, to open up your math journals to page 291. If you'd like to pause the video at this time to get caught up, open up to page 291, press pause. We're going to continue. On page 291, you can see we have a word problem here. The unlocked problem says the Healthy Wheat Bakery uses 560 pounds of flour to make 1,000 loaves of bread. Each loaf of bread contains the same amount of flour. How many pounds of flour does the bakery use in each loaf of bread? So we know the total pounds of flour that are used in the 1,000 loaves. Our job is to break that down to find out how many pounds of flour go into each loaf. So we're going to take a look at patterns here, and we're going to use the number expression 560 divided by 1,000 to find our solution. I'm going to skip over, and I want you to skip over the left-hand side of page 591 for right now. I don't want to confuse you, and let's take a look at some of these patterns. So the first number in our pattern, or power of 10, is to divide 560 by 1. We remember that anytime we divide a number by 1, that it doesn't change the solution. The number remains the same. So 560 divided by 1 is going to stay 560. Also keep in mind, there is an invisible decimal that we can't see right here at the end of every single whole number. So if I look at the number 10, hey, there's a decimal there that I can't see. It's invisible. All right, so there is a decimal right here. I'm going to go ahead and put it there just to remind myself, hey, there's a decimal there. The next power of 10 after 1 is the number 10. When I divide 560 by 10, look what happened to that invisible decimal. It scooted over in between the 6 and the 0. So 560 divided by 10 equals 56 and 0/10. So keep asking yourself, well, how is that solution affected when I divide by a power of 10? Well, I notice that it moved over to the left one time when I divided by 10. Take a look at the next expression in our pattern. 560 divided by the next power of 10 would be 100. And look what happens. We start again at the same place. This time we move the decimal over not once but twice. So our solution is 5 and 60 hundredths. So notice when we divided by 10, the decimal moved over one time. When we divided by 100, the decimal moved over not once but 2 times. The next power of 10 is 1,000. When we divide 560 divided by 1,000, look what we're doing. We're moving the decimal over once, twice, 3 times, so that it actually ends up at 0.560. And we say that number, or pronounce that number, 0 and 560 thousandths. So our answer was actually less than 1 whole. So on page 291, halfway down the page, you'll see a blank. So blank pound of flour is used in each loaf of bread. We know our answer, and we can write that down. It's right here. So each loaf of bread uses 0 and 56 hundredths pound of flour, or you could say 0 and 560 thousandths loaf or pounds of flour. Let's go on to take a look at another one. We did look for a pattern in that, I'm sorry, we're not moving on, but back to the same expression. What pattern did you see? All right, so I noticed there was no 0 on the end of the 1. So when I divided by 1, I moved the decimal no places to the left. When I divided by 10, I moved the decimal 1 time to the left, and I noticed that this had 1 0 in it. When I divided by 100, 100 has 2 zeros in it, I moved the decimal to the left 2 times. How many times did we move the decimal to the left when we divided by 1,000? 3 times. Why did we move it 3 times to the left? I noticed we have 3 zeros in our 1,000. All right, another way, using exponents. We talked about exponents a few lessons ago. Let's look for a pattern again when we're dividing by powers of 10 that are represented in exponential notation. All right, so we're still looking at 560 divided by 1,000, but we're writing 1,000 now as 10 to the power of 3. Remember that 10 to the power of 3 is the same as 1,000. All right, we remember when we write 10 to the power of 3, it's like the number 1 with 1, 2, 3 zeros behind it. So we're still dividing by 1,000, all right? If we divide 560 by 10 to the power of 0, remember 10 to the power of 0 is 1, so the decimal doesn't move at all. Divide it by 10 to the power of 1, which is the same as 10, we're going to move the decimal to the left one time. Dividing it by 10 to the power of 2, decimal moves to the left 2 times. If I divide 560 by 10 to the power of 3, how many times is that decimal going to move to the left? Yeah, it's going to move 3 times to the left. So when I move it 3 times to the left, it's going to end up to the left place of the 5, so 0 and 560 thousandths. Each divisor or power of 10 is 10 times the divisor before it. How do the quotients compare? So think about that. Each divisor, remember that a divisor is the number that we're dividing by. So in this case, it's 10 to the power of 0, 10 to the power of 1. Each divisor or power of 10 is 10 times the divisor before it. How do the quotients compare? Well, if you look at the quotients, each quotient seems to be 10 times smaller than the quotient that came before it. So 56 is 10 times smaller than 560. 5 and 60 hundredths is 10 times smaller than 500 or than 556. So each one seems to be 10 times smaller. Another way to say that is each quotient is 1/10 of the quotient that came before it. So that's page 291. I'm sure that you still may have some questions about dividing and answering our lesson essential question, how is the solution affected when dividing by powers of 10? So we'll do a few more problems together. I'm going to go over to page 292, where we see another example. Top of page 292 says Liang used 25.5 pounds of tomatoes to make a large batch of salsa. Yummy. He used 1/10 as many pounds of onions as pounds of tomatoes. So think, I know how many pounds of tomatoes he used. He used 1/10 the amount of onions as he did tomatoes. He used 1/100th as many pounds of green peppers as pounds of tomatoes. How much of each ingredient did Liang use? So we're going to think. For the onions, he used 1/10 pound of onions. So I'm really dividing that by 10. 1/10 the amount is the same as dividing a number by 10. For the green peppers, it says that he used 1/100th the amount of green peppers as tomatoes. So I'm taking the number of tomatoes, and I'm finding out what 1/100th of this number is. To do that, it's the same as dividing by 100. So now I need to think. Well, I remember, when I divide a number by 10, it has 1 0 in it. I'm going to be moving this decimal 1 time to the left. So think, 25.5 divided by 1 is, of course, 25.5. So I'll jot that down. 25 divided by 10, I remember, yep, I move it to the left 1 time. So the decimal is now resting in between the 2 and the 5. So Liang is going to use 2.55 pounds of onions for his batch of salsa. For the green peppers, I'm going to use that pattern again. If he divides 25.5 by 1, or I'm sorry, if we do that, the first pattern shows our solution is 25.5. If we divide it by 10, I'm going to scoot that decimal to the left 1 time. And that's how I got my answer for the number of pounds of onions he needs, 2.55. But now when I divide by 100, notice I got I have 2 zeros in my divisor. So I'm going to move that decimal to the left 2 times. So my answer is going to put the decimal in front of the 2, and it's going to give me 0.255. Excuse my sloppy handwriting. So what this tells me is it tells me that Liang loves lots of tomatoes in his salsa. He likes a little bit of onions in his salsa. There's not a lot of green peppers in the salsa. That's much less than 1 whole pound of green peppers that go into his salsa. Let's take a look at the try this on page 292. And I want you to try to do this by yourself. So see if you can complete letter A and letter B. I'm going to give you an opportunity to pause the video right now and complete letters A and B. All right, so let's see if we get the same answers. I know when I divide any number by 1, I'm coming up with the same dividend, or the same number, 32.6. When I divide by 10, 10 has 1 0 in it. I'm moving the decimal over to the left 1 time, so it's going to give me 3.26. And when I divide by 100, the next power of 10, I'm going to move the decimal to the left 2 times because 100 has 2 zeros. So, oops, it's 0.326. In example letter B, we're dividing by 10 to the power of 0. I look at the exponent, it's a 0, so I'm not going to move the decimal at all to the left. 50, ooh, that's a sloppy 0, 0.2. If I divide by 10 to the power of 1, the exponent 1 tells me to move it to the left 1 time. So my answer is going to be 5.02. And if I have an exponent of 2, we're going to slide that decimal to the left 2 times. So our answer is going to be 0.502. All right, how did you do with those? Did you get them all right? Do you need more help? If you do need more help, be sure to check in with your teachers during your check-in time at 1 o'clock. If you don't need more help, I wish you luck on completing today's math assignment, and I look forward to seeing you in person on your next scheduled day. Have a great day.